The normal distribution. If you think about the heights of your friends, it's quite likely most of them might be around 180 centimetres. Some will be a bit shorter, some will be a bit taller. We could draw out a frequency polygon of their height. It might look a little bit like this. I can make a better job of that. This should be symmetrical, this frequency polygon. Yeah, it might look a bit like that. 180 centimetres is the most commonly occurring height, and then the extremes, the very tall people and the very short people, fall outside of those, well, fall towards the edge of the distribution. For a normal distribution, probabilities are given by the areas under a curve. So you might say that, if I could use a different colour for this, you might say that the distribution is modelled or approximate to a normal distribution, and a normal distribution follows this same shape. However, instead of having a mean value of 180 centimetres, you have a mean of 0 and a standard deviation or a variance squared of 1. And that's how you write out normal distribution, a mean of 0 and a standard deviation of 1. So if we look here, you could put on one standard deviation away from the mean, either side, and you could in fact go 2 times, 2 standard deviations away, 3, 4, and so on. So our normal distribution, our modelled distribution of the normal distribution, has a mean of 0 and a standard deviation of 1. So 1 would be here, 1 would be here, minus 1 rather would be here, and then that could be used to work out probabilities of people being of a certain height. You can use the variable z to model the normal distribution. So instead of saying so many standard deviations away, we say we're going to use a variable, and that variable is z. You are sometimes asked questions such as, what is the probability that at some point on the distribution, z, sometimes we might say this is an outcome, is less than a certain point on the graph. The probability is actually the area under the curve. So if you asked what is the probability that z is less than 1.52, z being 1.52, or our outcome z, sometimes shown by an x or a lowercase z, is less than 1.52. What we're really asking is, excuse my drawing on this one, 0, there's 1, there's 2, 1.52 might be here. What is the area underneath this graph to the left of our point here of 1.52? Now, we could do some very complicated maths to work out this area, but someone's done the hard work for us and put the information into tables, so we need to look up a z value for 1.52. If I turn to my z table, I can see that 1.52, the area under that part of the graph, 1.52, is 0.9357, and that's a decimal probability. So the whole area under the graph is 1, 0.9357 of the graph. It's a dimensionless area, but if we're going to convert that decimal probability to a percent, 93.57% of the area is to the left of 1.52 on our graph. If we try another one, we might be asked, what is the probability of an outcome being less than or greater than, we'll say 2.60. Always draw your diagram on these. Oh, that's not straight enough even by my standards. So we've got 1 standard deviation, 2 standard deviations, these are Z values, 3 standard deviations. We're looking at 2.60. Look at our greater than, less than sign. We're saying greater than, so greater than is above 2.60, so it's up to the right of the distribution. Our tables usually only give values from 0, Z values from 0 up to 1. They don't give the negative side of the distribution, and that's because the distribution is symmetrical, so we can work out areas here and use that information to work out what they would be at the other end. Also, we sometimes have to use the figures we get to work out when we're asked for probabilities greater, the probabilities of an outcome greater than a threshold amount, because we only get information on the area under the graph to the left of a certain point above 0 on the distribution. So when we're asked what is the probability that a certain outcome is greater than a threshold value, we need to do a little bit of maths to make sure that we are looking at the right or the correct side of the graph. So if we look at our table, it can tell us the area to the left of this point on the graph, a Z value of 2.60. The area there would be 2.60. So Z is less than 2.60 or 2.60 being greater than the Z value, or than the probability of the outcome falling to the left of the threshold point. That's what the information gives us. The probability of the value falling to the left of the threshold point, 2.6, is 0.9953. Because the total area is 1, we can say 1 minus 0.9953. Let's just make sure we get this right. 0.9953. Let's move this down a little bit. Not lined up very well, but we'll cope with that. 10 minus 3 is 7. 9 minus 5 is 4. 9 minus 9 is 0. 9 minus 9 is 0. So then we're looking at 0.0047. That's to say it's 0.47% probability that our outcome is greater than 2.6 standard deviations away from the mean. Let's try one more. Let's look at the other side of the distribution. We're looking at values less than 0. So what is the probability of an outcome being less than minus 0.75? So there's 1 standard deviation either side. Stick another one on there, why not? Minus 2, 2. We're looking at this point here, minus 0.75. So we want this area here. We've only got positive area, and we can only use the tables to work out the area to the left of the graph. The best way for us to do this is say, well, we can work out this value, and if we subtract the yellow value, or the yellow area from the whole area, and the whole area is 1, we're going to get this area I'll colour in blue. And because the graph's symmetrical, we could go 0.75 there. It's not what we've been asked for, but we could work out this area. And 1 minus the yellow area will give us the blue area, and the blue area is equal to the red area. So let's quickly do that. Let's go back to our tables and look at how much of the graph, how much area there is to the left of our normal distribution if we're asked what is the probability the outcome is less than minus 0.75. 0.75 standard deviations away gives us a probability if Z is 0.75. The probability as a decimal probability is 0.7734. So that's the yellow area. Then the remaining area is 1.0000 minus 0.7734. Let's quickly do that. Six, 2, 0.2266 decimal probability of an outcome being less than minus 0.75, which is the area we wanted here. And we've used it by using symmetrical, like the equivalence of the areas under the graph. We've said that this blue area is the same as the red area to complete that calculation.